Hooray! Welcome to Quarkus Insights 111, which is very pleasingly one-full as a number.
That's
So
true.
we've got three of us today. So I'm Holly Cummins. We've got Max, if you want to introduce yourself.
I'm Max, co-leading Quarkus and try to be on the Insights view from time to time. So yeah.
And we've got our guest, Loïc. So do you want to introduce yourself?
Hello, so I'm Loïc Mathieu. I'm an IT consultant at Zenica, and I contribute to multiple extensions for Quarkus.
Hooray! And what are you going to be talking about today?
Today we are talking about what's new with Google Cloud Functions. So it's been more than 1 year last time. I think we talked about Google Cloud Functions and Google Cloud Service support. So there is some news we'll talk today.
Cool.
Nice.
So, yeah, have you got slides?
No, because there is no slides on for Quarkus Insights. It's not allowed.
Yeah. All of the guests, we turn them
Disturbed.
upside down at the door and shake out any slides.
Yeah. So just before we get on, I just wanted to remind people. So last week we talked about it on what's that, Monday, and we released 2.13 and 2.14 because of the CVE in dev mode. So just again, if you are running on old version of Quarkus, please upgrade or see the release blog where there's a way to work around the CVE. But yeah, it's serious enough that we want to keep reminding people to update because people can literally randomly execute stuff on your local host if you don't update. So yeah, anyway, I don't want to make this, but anyway, update the latest of Quarkus, or if you use something older, like before 2.13, go see on the blog on how to avoid the issue. Cool. Back to the normal program.
Oh. So what's new with the...
Okay.
Well, actually, before we start with what's new, can you give us sort of a quick introduction to what the Google Cloud Functions extension does?
Yes, of course. So Google Cloud Functions are the serverless function as a service solution for deploying a Quarkus application to Google Cloud. So you can deploy a Quarkus application in multiple ways, but if you want to deploy it in a serverless with a function as a service framework, you will use Google Cloud Functions. We have multiple ways to build a Quarkus application for Google Cloud Functions. You can use the Google Cloud Functions API. You can use any of the HTTP service, HTTP extension of Quarkus. So you can build your function with REST-easy, Servlet, Vertex Web. This is reactive routes now. Spring Web. So any of the HTTP framework. Or you can use Funky. Funky is cloud agnostic serverless API of Quarkus. So with Funky, you can write Google Cloud functions without the Google Cloud API. So a function that we can then deploy to a different cloud provider if you want. So this is the three ways to build Google Cloud Functions.
Do you have sort of a heuristic for how you choose between the three?
How? I would say if you want to build an HTTP functions, really the easiest way is to use what we call Google Cloud Functions HTTP. So the extension that allows you to use one of the HTTP extension of Quarkus. I will say REST-easy because it's the easiest one. So, well, if you want to make an HTTP function not trivial, you should use it. If you just want to make an HTTP function that's just respond hello, you can also use the Google Cloud Functions API, but yeah, the API just gives you access to a request and a response object, so it's really low level. And if you want to develop an event-based function, what is called a background function in Google Cloud, there Frankie is a really good choice. But you can also use Google Cloud Functions API. It depends if you want to be coupled with the Google Cloud API or not. Because Frankie may be a little more limited in what you can do.
Yeah, that makes sense. You get the abstraction, and you get the benefit of the abstraction, but you get the penalty of the abstraction too.
Yes. But yeah, and so if we talk about what's new, first there is Cloud Function v2. It's not really dependent on Quarkus, but we upgrade the function runtime to be able to work on Cloud Function v2. With Cloud Function v2, there is support for Java 17. There is support for more concurrency inside the function. So with Google Cloud Function, you can have a single function instance that supports multiple requests concurrently. And with v2, you can support way more requests concurrently. So this will reduce the cold start, because you will have less cold start, because one function instance can handle more requests. And the big news for me with Google Cloud Function v2 is that you can use Cloud Events. So we also upgrade the guide, and we also in fact support Cloud Events function because this was a new kind of function. And Cloud Event functions is now my preferred way to to write a background event.
Can you give a bit more background on what cloud events are?
Yeah, for those who don't know what cloud events are, it's just a way to describe an event in a standard way. Yeah, okay. So this is a specification that will specify how to describe the event metadata, and it is supported in a lot of cloud providers, in a lot of frameworks, and there is event binding for multiple technology. For example, if you build a cloud event functions in Google Cloud, you can reuse most of the same code to deploy in Azure, for example, or Instant Cloud, because they both support cloud event. It's also supported in knative eventing, multiple frameworks like DBVM, OpenFast, and there is bindings for Kafka and HTTP, so you can trigger a function with cloud events, then send the metadata to Kafka, then access the metadata from an HTTP endpoint. So yeah, it's really interesting, and you can now use a cloud event. So instead of having a native event from Google Cloud, you will have an event in a cloud event. So
nice.
So I hadn't even thought about it. Yeah. So cloud event is being adopted by all the different cloud vendors, and then you can write more. Except one. What's the except one?
Amazon Web Services didn't support cloud event yet.
Of course. Okay. Yeah. Actually, a question. Just because we came out last week, Amazon announced Snapstart, which Quarkus supports, which is this thing where they, instead of using a native image, you do a snapshot of the process and then restore it, which works somewhat well in Lambda specific use case, and it is Lambda specific functionality. But we had the fun. Sorry, the fun thing is that you could actually deploy a native image that would use less memory and less CPU than a Snapstart, but because of the pricing model that Amazon has, the snapshot actually wins, even though it uses more resources. But do you know, is it the same thing in Google Cloud? Like, do you actually get to pay less by using native image or Java or?
There is no native image support for Google Cloud Functions. If you want to use a native image with a serverless solution on Google Cloud, you will use Cloud Run. Cloud Run is just serverless based on containers. But the Google Cloud Function, it's really it's launched. It's a Jetty server that is started, and that will start your function.
Okay.
There is no native support in it directly.
Got it. Okay.
And so if you use it with Quarkus, does that mean you have Jetty and then Quarkus as well?
You have Jetty and there's Quarkus, and we kind of there is an integration between Jetty and the Quarkus HTTP stack. So we launch a native, and the native will discuss with Jetty.
Yeah, and this is. Oh, go ahead.
This is also what we did for Azure functions and Amazon Lambda functions.
It's a common pattern on Azure and Google and somewhat also in Lambda is that there is this extra layer of interaction, either via Jetty or a custom runner as in Amazon, it makes it harder for us to actually optimize some things, but you can't get the benefit of native image, for example, but you can get the benefit of fast execution and so on. But
Quarkus starts in less than 1 second in Cloud Functions, but you need also to start native, which Jetty for the Jetty of Cloud Functions, and it takes I don't remember, but around 2 seconds, maybe a little less. So it's still quick to start, but you still need to take care of cold start, and that's why the new Cloud Function v2 allows you more concurrent requests, and there is also I don't remember how it's told, but there is also a functionality to keep a minimum instance of functions running to avoid cold start.
Okay, yeah, that makes sense. So have you got a demo for us?
Yeah, I will do it. Can you share my screen?
There you go.
Okay, so if you go to Quarkus guide, you will see a different guide for Google Cloud Functions. So as I said, there is native Google Cloud API, Funky, Google Cloud HTTP, where you can use reactive routes, REST easy servlet, or Spring Web, and there is Funky with HTTP. It's a kind of it's very specific usage. So if you want to write Google Cloud Functions, you can use of course stats.quarkus code.quarkus.io, and there is cold start for Cloud Function. So for example, I will create Google Cloud Function with the native API. Okay, and I can then just download it. Okay, great. I will open it. Okay.
Just here, you can only see your terminal right now. But
yeah, just a few seconds. Yeah, okay. So
Cool.
after generation of the project, you will have code example for the three different functions that you can create on Google Cloud. So there is a background function. So this is a regular background function of Google Cloud. So it implements background function, and you then give it the class that represent the event. So this function will be triggered by uploading a file in cloud storage. This is our demo event function. And so you see, you receive a storage event. Here it's a class that I created that will just reuse the format of the event from the Google Cloud API.
And are these cloud events, or are these specific to Google Cloud, or does it actually not matter because one abstracts the other?
This one is specific for Google Cloud, and they didn't give the event as an SDK, so you need to create a class that represents the event. And the only thing that is not standard Google Cloud function API is that your function needs to be a CDI bin. Thanks to this, Quarkus will be able to locate it, and also will be able to inject any dependency in it. In fact, when you launch a function, you will not launch the function with this function class. You will use the Quarkus function class, and this is the Quarkus function class. Function class will locate your function, inject dependencies, and then just delegate each call to your class. Okay, so there is two functions. There is the Quarkus function, and the Quarkus function will delegate all calls to your function. So this is classic classic function. So first I will just check. Okay. So there is also an example of an HTTP function. As you can see, it's really low level, as I said. So if you want to write an HTTP function with the Google Cloud API, Google Cloud Function API, you will just have access to an HTTP request and an HTTP response. So you can do it if you want, but I think it's better to use REST-easy for this kind of function. And the Cloud Events function. So the Cloud Events function, it implements Cloud Events function. Again, this is coming from Google Cloud Function API. And here you receive a Cloud Event. So a Cloud Event, it's an object coming from the Cloud Event SDK. So it's just an interface that describes Cloud Event metadata. So here you have, okay, if you climb up the hierarchy of interface, you have the Cloud Event attributes that are the attributes from the specification. So you have the spec version of Cloud Events, the ID of the event, the type of the event, the source of the event, and then you have optional attributes that, like the subject, the data schema, if there is a schema, for example, for your JSON schema. As Cloud Event is cool, I will launch this function. So I will remove the other function because if there is multiple function, Quarkus will just throw an exception saying, okay, I don't know which function you want me to deploy. Then I will deploy it. So first, of course, I will need to build it. I will build my function. And yeah, okay. When you build the function, there is something different than a typical Quarkus application, because it will not use the Quarkus fast jar with multiple layers like when you deploy to a container. It will create another jar. It will be in the deployment directory. And this is this other jar that we will. Right.
And is that something that just happens as soon as you have the extension as one of your dependencies, or do you need to invoke the build differently to get the different jar?
Yeah, but this one is only 5 megabytes. It's not. It doesn't feel right. Normally it should work. Okay. I'm just surprised it's so small, but yeah, it may be. Okay, so then I will deploy the function, background function. No, the clear event function. So to deploy the function in Google Cloud, I will use the cloud functions deploy command. Okay, then I will name my function. This function is named Quarkus example cloud event. I'll use the Gen2 option to tell Google Cloud Functions that it need to use generation to runtime. The entry point, it's a Quarkus function. It's not my function. It's a Quarkus function. And here I specify the runtime Java 11, but Java 17 is also supported. And I will configure it to be triggered by the bucket example cloud event. So this is a cloud storage bucket where I can upload file, and uploading a file in the bucket will trigger my function. Then I just say that the source of the function is in the Git target deployment directory.
Oh.
Yeah, because yeah, it's just that I need to. I will use a different region. Sorry, cloud function.
Oh, it's complaining about the region. Okay, got it.
Yeah. No, not cloud region list.
That's the funnest stuff. It's so easy to deploy to cloud, as long as you get all the different new parameters right.
Yes. Simple. Okay.
Oh.
No, I should have.
Have I told you my theory about audience-driven testing?
Yeah, because I wanted to do everything from scratch, but instead of you were using one of my complex demo. But yeah, maybe I should have done another thing. Okay, so I can use.
What's your theory, Holly?
Oh, just that No matter how well tested you think you are, as soon as you go in front of an audience, you discover a whole new bunch of new bugs, and it's directly proportional to the size and importance of the audience as well. So, when you're presenting to your executives, then nothing works at all. Whereas, if you're just presenting to a mate, then it all works really well. And, if you're doing a large conference talk, then you've just got no chance.
Strange because
but you find loads of new defects. We just need to find a way of harnessing it. Simulate audiences.
Yeah. Basically, next time, make sure you tell the person that you're just a mate, but then you get the CEO person.
I just forget one. I will just open a solution. So I need to specify where is the trigger, because it will create a trigger in a region, and the trigger will trigger the function. Just a few seconds. I should have all the.
I figure if we could get it into GitHub Action, so you had like an extra parameter in GitHub Actions that said, I want 6 eyeballs on this.
Yeah, that will work.
Okay. I just need to add the trigger location command line argument to tell Google Cloud where is the location of the trigger. So this is using Cloud Build. It's different from what is when with Google Cloud Function Gen 1, it uses custom build. Here it will use Cloud Build, and it will also reuse Cloud Run under the cover. So with function Gen 2, it's your Cloud Function. We use other Google Cloud tools. It's no more custom build and custom runtimes. So it will deploy my function. So it will take some time, but there is very interesting thing that we will release next week. So I wanted to show you because it's really it's really great, because if you see here
CO1.
How can we test this?
I was going to ask, how do you test
if you want to test a Cloud Function, basically there is 2 ways. You can download an invoker jar. So you launch the jar, you pass it. I think it's documented here. It's not very convenient. I need to stop doing this. So you just download the Java function invoker. So this is a jar file that will launch a Jetty locator function and start it. Then you call it, and you give it a target class that is the Quarkus function. But it's just a local test, and there is no genuine test support. So when I saw this, I think, okay, it's a shame, because the invoker, it's a jar, it's open source, but there is no way to control the start and the end of the invoker. So I propose a pull request to the Google Cloud Function invoker, and implement what's needed to be able to control the invoker, so we can write genuine test. And this will be supported in Quarkus 2.15. So that's why I wanted to to show you this.
CL1.
Yeah. So with the next release of Quarkus, you will be able to write unit test for your function. Okay, so I will show you how it will work. So just generate test. Great. And this will be a regular Quarkus test. So a class annotated with Quarkus test to be able to launch Quarkus, and then you will be able to write a test. And there is dedicated support. You use an no. You need to add a test dependency. So this should be on the guide. So you need to add this dependency. Okay. So this is a Quarkus test Google Cloud function. So it provides test support for Google Cloud. And after adding this dependency, you have with function. The with function annotation will tell Quarkus to start a function invoker at the beginning of your test and end it at the end of your test. So it's just shows you.
So function invoker, is that like a dev service or a Google Cloud library thing?
Yeah. It's not a dev service. It will use the Java invoker of Cloud Functions and start it at the beginning of your test and end it at the end.
Okay, good. So it's like in process thing.
Yeah. This is really to be able to write a unit test. And you need to configure to tell the test support which type of function you use. So here I use a Cloud Event function, and then you can just use rest assured to send an HTTP request to the test to the invoker endpoint. So we have for Cloud Event, it's a bit complex because you need to send a Cloud event. But for example, if you use this to call a background event, you will just send the event in the body of the of rest assured, and it's just a regular rest assured.
So you're using JUnit, but they're more integration tests than unit tests, right? It's like black box testing of your function, right?
Yeah. Like what we usually do with Quarkus.
Yeah.
So for Cloud Function, it's a bit complex because the Cloud Function API mandates the Cloud Function specification mandates to have a lot of I don't have rest assured. Yeah.
Feels like you almost want another helper for that, of like sort of Cloud Function rest assured to fill in all that boilerplate.
Yeah. We can, because Yeah. Okay. I will explain it. It's not. Okay. Yeah. The cloud event metadata must be sent using headers because it is the standard way to send cloud events metadata via the HTTP binding. And then in the body of the request, this is the event itself. Because in cloud event, you will still have the event inside the cloud event. There is a data attribute where there is the event data. So here it's a cloud event. Okay. So yeah, this is this is your event data. This part is different. Can be different from cloud provider to cloud provider. And normally it should work. Yeah, you see, test is green.
Cool.
So,
can you do that with Jackson, or does it have to be sort of done by hand, all of the fields for the data?
Here you can reuse. Yeah, in fact, the data is just a byte array. Okay.
Yeah.
So you can use Jackson, for example, to parse it, and here it's the same. Previously I show you a class storage event. You can create a class storage event if you want to serialize it automatically and avoiding putting everything in a string like this. Okay.
Cool. Yeah, this is really nice.
So this is cloud event. It's new, and you also see that there is test support for cloud functions. This is also new. With this, we also decided to move the cloud function extensions to stable. Previously, there was in the previous stage. So now we consider the Quarkus Google Cloud Function support to be stable. This is also a milestone for Cloud Function.
How old is the extension?
More than 2 years, I think.
Wow.
Yeah, Loïc was on early on in the Insights talking about the first version of it. So.
And what is great with Google Cloud Function is to be able to use all the cloud services that Google offers. For this, you can use one of the extensions that the Google Cloud Services extension pack for Quarkus offers. So currently we support BigQuery, Bigtable, Firebase admin. This is really new. Firestore, PubSub, Secret Manager, Spanner, and Storage. So it's really great because you can create a function, and then this function can access the cloud storage, or can send a request to Spanner. And what is great is that when you run your application, your Quarkus application inside the function, you don't have to configure the region, configure the authentication. So it's easier.
Yeah, it's really handy.
So Loïc, just one thing I know that the Google Cloud team had announced I don't know, a month or two ago, that all their APIs would now be native image GraalVM compatible. Are these using that, or are they using our? What's the connection here?
So this is an interesting story, because I was the first to work on native support for Google Cloud. So all these extensions, first they provide first-class native support inside the extension themselves. Then I start working with the Google Cloud API team, and then they built native support for a lot of services. Then we worked together to replace what's inside our extension, but by what they provide. So we were the first to use the native support library. I sometimes still discuss with them with a native issue. So we were together on the Google Cloud Services extension pack regarding the native support part. And all these extensions works in native. I'm not sure for Firebase because I didn't test it yet, but normally everything related to Google Cloud Services works with native images.
So you would use it with Cloud Runner for native image, or with Cloud Functions if you didn't want native image?
Yeah, for Cloud Run, or you can also create an application that you deploy in Kubernetes or out of Google Cloud and still use Google Cloud Services.
Yeah.
And Google Cloud Services is also used a lot in Camel Quarkus. So these extensions are also already used, and I just moved them from experimental to preview. So also their maturity evolved lately.
Okay. So the going forward, the libraries itself will be native friendly, but we go an extra mile and hook up all the Quarkus goodness to it. Okay.
So, for example, if you want to use storage inside your function, you can use all the Quarkus tooling, because it's the Google Cloud Services extension pack are inside the Quarkus platform. So you can say, okay, Quarkus extension add storage. Okay. It's usually quicker than this. I don't know what's going on.
Audience-driven testing.
Oh,
Either that or the effort of streaming has just caused your computer to lose its connection to the outside world.
Yeah.
It's strange.
It shouldn't be that slow.
No. Maybe the clear repository is not, yeah. So basically this will add the DBOM. So to be able to manage all dependencies. This will do this. This will, sorry. Okay. And add storage. Extension.
What went wrong here?
Yeah, there is missing. Because it's in the platform, so it should be the same.
Well, you shouldn't have to have the version there. You have to just, if they're in the platform, you should be able to delete the version.
Yeah, but that's why I'm. Just a second, I will check.
Yeah. That should and live demo.
Yeah, of course. Where is it? Okay, yeah. Yeah, it should be quarkus.platform.version. What's going on? Oh, yeah. Sorry.
It's not, yeah, they're not published. Got it, yes.
Yeah. So my test will not work anymore, but I don't care. Yeah. So what's going on is that the platform is not released for candidate version. So there is no Quarkus Google Cloud Services in version 2.15.rc1. So I need to use the old 2.14 version, and with this my test will not work anymore. But okay, I don't.
Oh, no.
So my version is not correct.
It's the way of demos, isn't it? Because it looks quite sensible to me.
Wasn't the error in Quarkus? You had a...
Just have a look.
Yeah, well, everyone should just be using final version stable, hasn't moved. We'll be fine. Demos would be not be boring then.
With the CLI, everything works fine, so it's easier, but yeah. I can just show you another piece of code. It's easier this way because it's not a big deal. I just want to show you how to use cloud storage in a function. Yeah, this will just be. So this is the same kind of cloud function that before. So it implements cloud events function, and when you have the cloud storage extension, you can inject a storage object, and the storage object will allow you to get an object from bucket. So first you get the bucket, okay. The get will be where the object is located inside cloud storage, and then you can get a blob. A blob is an object in cloud storage, and the blob is the name of the blob must come from the cloud event on itself. So the here I just read the cloud event data as a JSON object. Then I get the name attribute. This will be the name of the file inside my bucket, and then I can just get the blob and load the blob. Load it with get content. This will be the bytes. In fact, yeah, this will be the bytes of the blob. So the two extensions really works fine together, because you can have a function that uses cloud storage, and you will not have to deal with the region where is your bucket. You will not have to deal with authentication, because there is automatic authentication between your function and cloud storage.
It's very nice. We've had a question come in. Can I write code that's either, I think we talked about this a little bit at the beginning, but we didn't actually get into this level of detail. Can I write code that's either deployed to a Google function or as a traditional web app? And if you did that, how would you structure your project? Would you have like two separated apps, or what would the best practice be?
Yeah, you will be able to do it with Maven profile, for example. This is a trick. If you don't know it, a Maven profile will allow you to have separate libraries for separate profiles. So you can have your code as with REST-easy, for example. You write your code with REST-easy, and then you have a profile where we can build your application with the Cloud Function HTTP extension for REST-easy. I can show you this extension, but you need to rebuild it, of course, because it's not the same runtime. There is one runtime is the Cloud Function, and the other runtime it's the Quarkus HTTP runtime.
And I guess you have to use Funky to make it portal, right?
Yeah, but even when it's Funky, there is a binding for Cloud Functions, a binding for AWS. But you can use the Maven profile trick to be able to build a function for each cloud provider and include the binding of Funky. Okay. Because if you use Google Cloud Functions with REST-easy very active, for example, you will have a JAX-RS endpoint, so you can launch it on the using the dev mod. You can make tests, but when you will build your application, it will integrate. It will add the Google Cloud runtime on top of it.
And would you also have some source folders that you would only include in each profile? Yeah.
Yeah, I prototype with Maven profile. I can just have a look. I need to yeah, this one. This was fun. Okay. If you're curious about how it can work, this is a demo of Funky. I made this demo a few months ago for a cloud conference in France. So yeah, I have no cancel. Yeah, so this is a cloud event function, and I have two profile, one for GCP, one for AWS. For GCP, the profile at the Quarkus Funky Google Cloud Functions, the extension that's where you can use Funky to with Google Cloud Functions, and the AWS profile at the Quarkus Funky Lambda, Amazon Lambda. So this is the binding for Funky for Amazon Lambda, and the other one is a binding for Google Cloud Functions. And then on your code, you just add the Quarkus Funky server common. This is a common library for Funky, and that's all. Okay, and here you use Funky. So with Funky, you have a method. You annotate the method with func, the func annotation, and this will be the function that will receive the event. So this is Funky.
Okay, cool.
Nice, yeah. So I guess we've got about 3 minutes left. So what are the final things to talk about, or any final questions? Or I guess, yeah, if we haven't got anything,
then we all good.
yeah, wrap up 3 minutes early. But,
So one
yeah.
question. I have one question. So are you using this? Is this for your own fun, or are you using it in production? What's the
people use this in production, but I didn't use it in production myself, because the current project I work on is using Google Kubernetes.
Yeah. Okay.
Yeah.
Got it. So you just have the fun and make it work. And
Yeah.
not to try out. Okay. Awesome. Cool. Well, Loïc, thank you, and 1,000 thanks for making Quarkus work great with Google. That's the key thing. Is all the different things, like the libraries for everything, but when you see people go the extra mile and having like test frameworks in place, or well, test server's not relevant here, but all those small things makes a big difference. So thank you for that, Loïc.
Yeah, really nice extension. Well, set of extensions.
Awesome.
Cool. So with that, yeah, I think we can wrap up. Thank you very much for the work on the extensions, and thank you very much for being a guest on Quarkus Insights as well.
Thank you.
See you all.
Bye.